Quadratic function is a polynomial function of degree 2. So quadratic function is a function of the form f of x equal ax squared plus bx plus c, where a cannot be equal to 0. A quadratic function can be expressed in the standard form of f of x equal a times the quantity of x minus h squared plus k by completing the square. The graph of f of x is the parabola with each k is the vertex. The parabola is open downward if a is less than 0 and open upward if a is greater than 0. Let's take a look at our first example. Given f of x equal 2x squared plus 3x minus 5, express f of x in standard form. F of x equal a times x minus h squared plus k. In order to do this, we will use complete the square. So let's walk you to how to complete the square. Okay, so let's start with the complete the square procedure. So given an expression ax squared plus bx plus c, the first step is to group ax squared plus bx. The next step is to factor out a out of the group in the step 1. And so what we get is a times x squared plus b over ax plus c. Third, divide b over a by 2 to get b over 2a. The next step, square the result in step 3. Then add to the expression. To get because we add into the equation, into the expression, we need to subtract it out right away. So if you looking at this, we add b over 2a into the parentheses, which meant overall we added b over a into the equation. So this is square. So overall we add a times b over 2a squared. That's a times b squared over 4a squared. That's b squared over 2a. Excuse me, b squared over 4a. And this is what we need to subtract out. So now the equation will become a times x squared plus b over ax plus b squared over 4a. And because we add, we have to minus b squared over 4a plus c. So this portion here is become x plus b over a square minus b square over 4a plus c. So then what we really did here is we'll go ahead and let h equal to negative b over a and k equal to negative b squared over 4a plus c. Then this equation becomes the standard form a times x minus e squared plus k. Okay. It looks complicated. However, when we do that, it's really simple. Okay, so go back to our problem. Start with the equation f of x equal 2x squared plus 3x minus 5. I go ahead and factor out 2 to get x squared plus 3x plus 3 over 2 x minus 5. The next thing I do is to take 3 over 2 divided by 2. 3 over 2 divided by 2 equal 3 over 4. Then square it. 3 over 4 square, that equals 9 over 16. I will add this into my equation and subtract it right away. So then 2 times x squared plus 3 over 2x plus 9 over 16 So because I have a 2 here, okay, so when 2 distribute over, it really here means we add 9 over 8. So then we subtract 9 over 8. Minus 5. This becomes 2 times x plus 3 over 4 square minus 49 over 8. So now we have an equation in standard form. So that is part A. Part B. We want to find the x and y intercept. So x-intercept is the value of x when y equal to 0, which means we set the equation to equal to 0. So 2 times x plus 3/4 square minus 49 over 8 equal to 0. So then x plus 3/4 square times 2 equal 49 over 8. X plus 3/4 square equal to 49 over 16. This means x plus 3/4 is equal plus or minus 7 over 4. X equal to 7 over 4 minus 3/4. that is 10/4, and this is 2.5. X equal negative 7/4 minus 3/4. Excuse me. This equal to 4/4. And this make 1. This right here make negative 10/4. That is negative 2.5. So here we have 2 x-intercept. 2 x-intercept at the point negative 2.5, 0, and 1, 0. Well, we need to find the y-intercept. So y-intercept is the value of y when x equal to 0. Okay, so we let x equal to 0 in the equation. So 2 times 0 plus 3/4 square minus 49/8. And what do we get? So 2 times 9/16 minus 49/16. This is 8. This is 9/8. Excuse me, 49/8 here. So the y-intercept is the point 0, negative 5. So let's put the x and y-intercept onto the graph. So x-intercept is 1 and 2.5. So let's say here's 1 and 2.5. 2.5 right here, negative 2.5. 1. And y-intercept is 5. Negative 5. This is our y-intercept. Okay. Now, because we have the equation in of the standard form, we know our vertex. Because the equation in the standard form, f of x is equal to 2 times x plus 3/4 square minus 49/8. Then the vertex is negative 3/4, negative 49/8, or it is negative 0.75, negative 6.125. So we got our vertex. That is somewhere here. Now we can draw our graph. And this is our graph f of x. Okay, this graph f of x have the domain of all real number. And the range starting from the lowest value on the graph, that is negative 6.125 to positive infinity, because this graph is open upward. So this is part C, graphing, and this is part D, the domain and range. In general, the polynomial function have the domain of all real number unless restricted otherwise.